Hello folks, it's Ms. Strong here, and we are going to solve equations today. We're going to solve equations with variables on each side. So they're going to look a little different, but they're going to follow the same rules that we've been following to solve equations all along. So let's just look first and notice that this guy has a variable over here on this side of the equals and also a variable on this side of the equals. Normally, when we attack an equation like this, we would say, well, I need to take care of these numbers that are next to the variables. I need to get them together. Well, now we have variables on both sides, so it's kind of like we need to get our variables together and we need to get our numbers together. And the way to do that is to add or subtract, depending on our sign, from one side to the other. So watch. If I subtract 3m from this side, then to keep my equation equal, I need to subtract 3m from this side as well. So on this side, it's like the 3m goes away and leaves me with just negative 5m. On the other side, 7m minus 3m is 4m. My negative 21 falls straight down. So if you look at the equation now, you'll notice that the end effect of subtracting that 3m from both sides is that now I only have a variable on one side, and I can start to think of this equation the same way I do any other two-step equation. I have to get rid of the number hanging out here first, and I will get rid of the 4 right in front of the m last. So these are the steps that we've done in the past. We're going to add 21 to get rid of it on both sides, or to work toward isolating the variable. Getting the variable by itself kind of means getting rid of these things next to it. So positive and negative 21 go to 0, and negative 5, positive 21. So two different signs. I'm going to subtract, and I think I'm getting 16. 21 minus 5 would be 16. 17, 19, 20. I don't like that. Now I have 4 times m, so I'll divide by 4, and these are the steps that I'm hoping you're a little more familiar with from solving regular two-step equations. M equals 4. Can we check our answer? But of course we can check our answer. We can always take what we think m is equal to. We can put it back into the original equation and see if we get a true statement. So let's just check on this one real quick. 4 times 3 is 12 minus 5 over here. 7 times 4 is 24 minus 21. And something is up. Is it 24? So it's at 28. That's why. Yeah, I can multiply. 28 minus 21 is looking like about 7. 21, 22, 23, 24, 25, 26, 7, 28. Goodness, I can't add today. And 12 minus 5, 7. So yes, it worked out. They match. They are equal to each other. When we put the 4 in, we get a true or valid equation. Okay, so this one has x's on both sides, variables on both sides, but it also has the distributive property. So we still need to simplify everywhere that we can before we start solving from one side to the other. So in this case, 4 times x, 4x, 4 times negative 6, negative 24. Yes, I can multiply by 4, can't I? Negative 2 times x, negative 2x, negative 2 times negative 3 plus 6. So watch that sign. Negative times this negative gives me a positive. Now this should look very much like the equation we did on the previous page. It has variables on both sides. We're going to look at those variables and go, oh, look, I always go for the smaller one, by the way. You can do either one. So in other words, there's two choices here. I can subtract 4x from both sides, or I can add 2x to both sides. If I add 2x, I won't get a negative variable, and that usually keeps me from making other mistakes. So I'm going to go with look at the smallest one and get rid of it first. But you can look at either one and get rid of it. 4 minus 2, 2x minus 24 equals, and here's my negative 2x, my positive 2x going away, and 6 is all that's left on that side. I hope you recognize a very simple two-step equation. Step 1, get rid of the 24 by adding. Step 2, get rid of the 2 by dividing. So here we go, add 24 to both sides. 24 and 6 is 30. 2x equals 30. I can divide by 2, and x equals 15. Can you check your answer? But of course you can check your answer. Put it back into the equation, use your calculator, any resources that you have. I would be checking answers as I went along if I were you. Now let's see what they can do to confuse us even more. Do you see the distributive property? That's the first thing I see here. I just see a number in front of parentheses. I see it twice, and I just want to send it through. So let's do that. 2n minus 6 plus 5 equals 3n minus 3. Now, I could, if I wanted to, just to throw out there, I could add 6 to both sides, get rid of the 6. I could subtract 5 from both sides to get rid of that 5. But that's not the wisest way to think about this. Because these guys are on this side together, they're on the same side of the equal sign, then I probably just need to combine them. So I'm going to leave the 2n alone. I can't combine it with a number because they're not like terms, but negative 6 and positive 5 together are minus 1 equals 3n minus 3. So now I have an equation that has variables on both sides, numbers on both sides. I'm going to try to get the variables together by looking at the smaller one and subtracting it away. So 2n minus 2n. Negative 1 equals 3n minus 2n is just 1n or n. Now I can get rid of the 3 by adding it to both sides. Why? Because I want this n to fall down here and be all by itself, right? It looks like n equals 2. It can start out looking really complicated, but it ends up in the same simple way. Equations just take practice. Solving equations take practice, but they're very formulaic. They follow the same pattern all the time. Let's see if we can make an equation to solve here. One side of a square is n plus 11. So they're telling me it's a square, and they're telling me that side's n plus 11. Another side is 2n. Well, that's kind of weird because I happen to know that squares have all sides that are the same, and I'm sure you know that too. So I think what that means is 2n must be equal to n plus 11. These two sides have to be equal, and they want us to solve for n. So when I have variables on both sides, I'll subtract n. 2n minus 1n, remember that. It's not the n's going away, it's 2n minus 1n, and what's left is 1n. So I'm going to write that as n. 1n minus 1n goes to 0, n equals 11. Let's just play with it. Is 2 times 11, 22, and 11 plus 11 is 22. So that seems to work out just fine. N is 11. These expressions describe the sides of that square. How about one more little wordy guide? In the class election, you received 41 more votes than your running mate. 41 more than your running mate. In all, 114 votes were cast for the two candidates. How many votes did each receive? Interesting. So you received 41 votes plus the number of votes that your running mate received. So I'll call your running mate R. This is what they were kind of looking for you to be thinking about. You or your number of votes, and I made that a Y, your number of votes is equal to 41 more than your running mate. At the same time, you know that you and your running mate equal 114 because they told us that's how many votes were cast all together. So one way of thinking about this is that Y is 41 plus R. And I could think about putting that into this guy. There's different ways to think about it, but this is the way it works and comes into my mind. If I let me be 41 plus R, then R, which is the number my running mate got, that should equal 114. So let me just stop a second or slow down and point this out again. 41 plus R, that's how many votes I got or you got. And then your running mate, they made this number R, and together that's 114. So we can solve this equation to find out how many each one of you got. So 41 plus R plus R. I get 41 plus 2R. That equals 114, and I can solve that by subtracting 41 from both sides. And I'm going to come up to the top, and I'll have 2R equals, and I'm going to use my calculator, 114 minus 41, just to make sure I don't muck it up. Whoops, try that again. 114 minus 41, I get 73. And then divide that by 2, and it looks like I've put kind of a funny problem on here because it looks like I'm getting an uneven number, and you can't have an uneven number of those. So that would be my fault for writing the question and changing the numbers without checking it out, probably. So if this is true, then I get an uneven number, which again probably is me mucking up the problem. You probably cannot get a decimal for a number of votes, right? So we should have come out with a whole number. You will come out with a whole number when you do the one that you are being asked to do in your homework. I changed the numbers here and mucked this one up, sorry. Let's try the last one, except that is our last one. Yay. Okay, go do your homework. See if you can do a better job. See if the one that you do will come out with even numbers, and I'm certain that it will. I put these two numbers in. You're going to see one with a little bit different numbers, and your numbers are not going to give you a decimal in the end. You're going to get a whole number. All right, go work on your homework, please, and come to Toga or